Morning, guys. All right, this is the video for simplifying radicals part 1, okay? Remember, when we're simplifying radicals, what we're looking for are perfect squares. In your math binders, you have your multiplication charts. I happen to print one off, and you can notice the nice color coding, right? Remember that these are your perfect squares, right? 2 times 2, 3 times 3, 4 times 4. So we're looking for that when we simplify. So the first one you see is the square root of 92. All right, well, I look along here and I notice that in itself is not a perfect square. So let me start to break it down into its factors. I don't know a lot about 92, but I know that 2 can go into it. So I'll break it down like that. Same thing, I still have an even number. So I'm gonna break that down again. Okay, I know that's a prime, I know that's a prime. Oh, and 23 is a prime. Remember, those are numbers that only have 1 and itself as a factor. So I can break that down to 2 times 2 times 23. But then I see that I have a pair there. So really, 2 times 2 would look like that. But now I have a perfect square. I know what the square root of 4 is. That is 2, so that comes outside the radical. And that is my final answer. Okay? Let's try the next one, square root of 49. Well, I look along here and hey, look what I figured out. I already know that it's a perfect square. So I can even kind of skip all that and just say, hey, I know what number times itself gives me 49? 7. So that one's done. Okay? Okay, let's try a few more examples. Square root of 50. All right, well, I could break this down a few ways, but I think I'll break it down to 5 times 10. It's a prime, it doesn't break down anymore. 2 times 5, okay, so now I'm down to my prime, so again this would look like 2 times 5 times 5, there is a pair, so then again it would maybe look like this, and oh yeah, there's my perfect square. What is the square root of 25? No, it's 5, so that would become 5 root 2. Final answer on that one. All right, let's try another one. Square root of 54. Well, what do I have? I have factors of that, 6 and 9. Okay, both of those can break down some more. That's 2 times 3, and that's 3 times 3. And those leave me with all primes. So okay, well, I see one pair there, but then I don't have a pair for either of those. So let's look at this, right? 2 times 3 gives me 6, so I can leave that there. 3 times 3 gives me 9. And there's my perfect square again. So that can come out of the radical. So that reduces to 3. And then this is not a perfect square, so that gets left behind to 3 root 6. All right, 2 more examples to do together, and then I'll have you work on your own. These are going to be a bit bigger, and I wanted to have us do a few of these. So the first one is square root of 300, right? So that has a lot of factors. All right, well, I'm going to start with 3 times 100. And then, I don't know, I could do 10 times 10. And each of those breaks down. Okay, so again, let me get all those in there. I'm going to put them in numerical order. That gets them all. 3, 2, 5, 2, 5. Okay, and again, looking for pairs. And I see a pair here and a pair here. Okay, so right now I'm going to multiply those because that's going to give me my perfect square. I'm going to leave this inside the radical because that won't break down anymore. then 5 times 5 would give me 25. But so now again, here I'd have my perfect square, and here I'd have a perfect square. And what is the square root of 4? It's 2. That gets left behind right now. And then what's the square root of 25? It's 5. Well, again, if things are outside the radical, I can multiply those. So that would simplify to 10 root 3. Okay? A little more complicated, but still the same process. All right, let's do the last one. Again, and this one's going to be extra ugly. Square root of 216, okay? And again, like that's not on my chart, so I'm going to pay attention to the fact that it's an even number so that I know it can be broken down 2 times, it's going to be 108. Okay, that looks familiar. I think that's going to be 9 times 12. I'll break that. And break that down to 3 and 3. I can break that down to 3 and 4. And then I'm way down here, 2 times 2. So this one has a lot of prime factors. So let me make sure I get them all. So it looks like I have 1, 2, 3 of those. And okay, I think I got them all. Now look at the pairs that I can find here. So I can find a pair of 2s here, not another, oh, I can find a pair of 3s, right? I could have circled those as well, it doesn't matter. Okay, so here's what I want to do. I want to break these apart now. So that would turn into, if I multiply those, square root of 4. If I multiply those, that would become square root of 6. And if I multiply those, that would become square root of 9. But then again, I know that where I found those pairs, I have perfect squares. So square root of 4 is 2. Square root of 9 is 3, and then that gets left behind. So square root of 216 simplifies all the way down to 6 root 6. And that is simplifying radicals, part 1.